Hi dear students of plus 2 medical, non-medical, respected teachers. So today I am going to discuss a very important topic, which is Bohr's quantization condition and its explanation on the basis of de Broglie hypothesis. Now, what is Bohr's quantization condition? So Bohr's quantization condition states that total angular momentum of an electron revolving around the nucleus is quantized and it is equal to integral multiple of the factor h upon 2 pi, where h is Planck's constant, so n is equal to 1, 2, 3. So MVR is equal to n into h upon 2 pi. This is known as Bohr's quantization condition. Now, after a few years from Bohr's proposed model of atom, de Broglie derived this Bohr's quantization condition using wave concept. He said, or according to de Broglie, every moving particle is associated with a wave called de Broglie wave or matter wave. Similarly, an electron revolving around the nucleus in a certain orbit, circular orbit, must also be associated with a wave called particle wave or de Broglie wave. So each electron revolving around the nucleus is associated with a wave called de Broglie wave, and if Rn is the radius of the nth orbit of the electron revolving around the nucleus, then total distance covered to form wave is equal to circumference of the circular orbit is equal to 2 pi Rn. Now why we are taking total distance covered is equal to 2 pi Rn? For that, suppose we have a string which is fixed at both ends. When string is plugged, a number of waves can be produced, but only those waves which form nodes at the fixed ends of the string will survive. Or we can say that if total distance covered moving down the string, that is from one fixed end to another fixed end and then back, should be an integral multiple of the wavelength of the wave. So such waves are called stationary or standing waves. It means standing waves can be produced only if total distance covered around the trip must be equal to integral multiple of the wavelength. Other waves having other wavelength will vanish quickly. So standing waves will be produced only if the circumference, because in the circle there is a circumference of circle, that is round trip, 2 pi Rn must be equal to n lambda. Such orbits for which this condition is satisfied are known as permitted orbits, stationary orbits or stable orbits. So according to de Broglie, 2 pi Rn must be equal to n into lambda. Then standing waves will be produced. So for example, if n is equal to 4, so for n is equal to 4, this orbit, say for example, it produces 4 waves like this, 1, 2, 3 and 4. So these waves are known as standing waves or stationary waves, just like stationary waves or standing waves between the two fixed ends of a string. So then, according to de Broglie hypothesis, the wavelength of wave associated with the particle is given by lambda is equal to h upon mvn. This is known as de Broglie wave equation, where Vn is the velocity of the electron in the nth orbit and mass of electron h is the Planck's constant. So from these two equations 1 and 2, we had 2 pi Rn is equal to n, substitute the value of lambda, h upon mvn, or mvn Rn is equal to nh upon 2 pi, where n is equal to 1, 2, 3, which is nothing but required Bohr's quantization condition, which has derived on the basis of de Broglie hypothesis. So, which states that total angular momentum of the orbital electron revolving in a particular orbit is equal to integral multiple of the factor h upon 2 pi. Means total angular momentum of orbital electron is always quantized in nature. Moreover, we can say that this wave duality particle character, particle has dual character. The dual character of particle sometimes behaves as particle, sometimes it behaves as wave, plays an important role in the study of structure of atom. So this is Bohr's quantization condition and its explanation on the basis of de Broglie hypothesis. So last, in this I will also discuss limitations of Bohr's theory. So there are some limitations of Bohr's theory. Bohr's theory fails to explain, because Bohr's theory is used, it explains the spectral lines of hydrogen-like atoms having Z is equal to 1. But it fails to explain the complete spectrum of atoms having Z greater than 1. This is one of the limitation. Second limitation, it fails to explain why only circular orbits are considered, because elliptical orbits are also equally possible. Third, since a spectral line splits into two or more spectral lines under the influence of electric field called Stark effect, under the influence of magnetic field called Zeeman effect. So this splitting of a spectral line into two or more spectral lines under the influence of electric or magnetic field is known as fine structure of the atom. So it could not explain the fine structure of the spectral lines even for H atom. This is third limitation. Fourth, it could not explain the relative intensities of spectral lines. कोई formula drive नहीं किया सी किन्नी किन्नी intensity होएगी, कितनी intensity ਵੱਧ होएगी, कितनी intensity घट होएगी. And fifth, it could not explain the wave nature of electrons, particles, the wave properties of particles, like electron is associated with a wave as according to de Broglie. These were 5 limitations of Bohr's theory of H atom. So this is all about Bohr's quantization condition and its explanation on the basis of de Broglie hypothesis and limitations of de Broglie limitations of Bohr's model of atom. Thank you. In the next video I will discuss atomic nuclei and its characteristics. So stay tuned till then. All the best. Good luck. Be happy. Stay tuned. Sarbat da Pala.